Okay. Well, hello there to you, viewer from across the tubes. It is I, Gnarly Quack, and that was a bit of a disaster. Firefox crashed on me just as I started the scream, so the stream, so I had to relog back into Twitch and everything. But thankfully, nobody typically watches me, so I doubt anybody was waiting. Of course, now that I turned my camera on, I I ran out of coffee and I should go refill my coffee, which is probably what I was going to do before Firefox crashed on me, but there you go. So I wonder if I should just start things off with a beverage break. I guess I am. Screw it. You know, it's a lazy. It's a weekend. It's a Saturday. We can take beverage breaks. We can start things off with a beverage break. So I'll be back in a second after I refill my coffee. Yeah. Okay. I suppose we can maybe actually start to get some work done here. Uh, Now one downside to me streaming while the sun is still up is now the world can see just how desperately overdue I am for a haircut. But oh well. So what am I doing here? I'm working on my TOML parser. Hey, Bazin. How are you? Happy, was it Saturday night? Pretty late Saturday night, I guess, huh? Getting on to midnight? How's your, oh, nice. How's your, yeah. How's your weekend been so far? Your first half of it, I guess. So I have kind of a quiet Saturday going on. Went out last night. Slept a lot this morning into the into the afternoon. So I'm at least gonna get the lecture on this finished up. We'll see how far we get into parsing. But other than maybe watching some movies tonight and getting some dinner going, this is pretty much what I have today. So see how much coding we get done before I get tired out. And we are on to arrays. Oh wow. That is very, you're very motivated if you're waking up at 6 on a Saturday to go work out. Good on you, though. Good on you. I woke up, I think I woke up at 7, immediately rolled back over and fell back asleep till sometime after 9. Then I got up, and I took a nap at like 11, and slept till like 1:30. But a friend of mine who was out with us last night, she slept until like 1 o'clock. So that's the kind of night it was for us, I guess. Yeah, I have tried so many times to become more of a morning person, and I would probably have less guilt if I. Oh, you know what I need to do though? I guess it doesn't really matter in this, but I need to bring my um, virtual environment up. But every time I try and is that it? Become more of a morning person, I just the first time I have like a well, I always have a hard time getting to bed on time, regardless. But then it's like the first time I have a night off, or it's like not a school night, so to speak. I stay up way too late, and I just completely throw off what little schedule I have. Yeah, I'm just I just probably need to have better discipline. We just went out to dinner last night. They do a thing called Restaurant Week here in Chicago during kind of the middle of winter for well, it's actually 2 weeks, but all the restaurants have uh, basically they have a fixed like a special fixed menu at like a fixed price, and basically every restaurant you go to will have some sort of menu for I can't remember what it is right now. $42 I think for dinner. So we went out to like a steakhouse last night, which all my friends were giving me a hard time because even though I grew up in Chicago, I never really been to a Chicago steakhouse. So everybody's giving me a hard time that it was my first time at a steakhouse. But it was pretty good. It was pretty tasty steak, I have to say. Although my friend who's into meat, he said he's had better, so at least better in Chicago. But sometimes not knowing that there's better means you can enjoy what you have, you know? I do have coffee. I do. It is a this is my morning coffee still. That's the kind of day it's been for me. We're doing a raise, I think. Yeah. So where we have? Well, I guess we should throw these examples in here. Uh, so I guess we're just going down here. So let's just do, oops, integers, 1, 2, 3. And you know what? Let's go crazy. Let's just do all this. And I keep saying I'm done typing this in, and I start typing it all in. So let's do this. All right. Oops. All right, and we'll have to throw that in there. And now just escape everything that needs escaping. Gotta escape that. Oops. Oops. That's not what I wanted to do. Don't think I need to escape those. Uh-oh, they have inline tables in here. So we're going to comment this out. And let's see what happens here. I do, yes. I do. It's well, there's a lot going on. Things are a bit chaotic, I feel like, in some sense. Um, some of the code I'm looking at is in pretty rough shape, but I'm remote right now, so after working in restaurants through the pandemic, I'm very grateful for that. And the people I work with all seem pretty cool, so it's kind of like, the environment is almost more important to me than sort of the what kind of code messes I'm getting into, because code messes can be fixed, hopefully. I guess that's not always true. It depends on the environment, but if you have a good environment, right? If you have a good work environment, that kind of makes all the difference, you know? Some things can be fixed, I guess is what I'm saying, and others can't. And if you're in a position where things can be fixed, then that's good. So, and then I like having the flexibility of being remote, I guess. I'm not sort of stuck in front of the computer for 8 hours a day. I can sort of take a break and then work a little bit later, sort of after the workday. So the flexibility is pretty nice. I've got that hanging there. I need to take that off. Oh, nice. Would you get a fancy like mechanical one or one with a bunch of lights on it? I really like my mechanical keyboard, but I bought like this $30 cheapo and it shows. So one of these days as a present, and actually my birthday's coming up. So maybe I'll splurge. I have a new job and everything, although I'm spending a lot of money on some trips that are coming up. Yeah, that's about what I'm looking at. What'd you get? Anyway, to finish my thought, maybe I can splurge on getting myself a new keyboard because uh, I'm just using a non-mechanical keyboard for my work computer, and I really miss having this, so I can maybe grab the nice one. Well, I don't know. I type more on my work keyboard than this one, so maybe I can leave this one here and use my nice keyboard for work. I don't know. What am I doing here? I'm trying to Lexus, I guess. But I remember I was shopping around like last summer, and supply chain stuff. It seemed like keyboards were in a lot of places that carry them. Whatever I was looking for. What am I doing? I'm checking if this is that, I suppose. Then we're going to want to Lex an array. But a lot of places seem to be out of stock on all their keyboards. Uh, I don't know. I guess we'll just stick this here at the bottom. Wait, why does that? Oh, I know why. Huh. Yeah, there's a store here in the US called like mechanicalkeyboards.com, but it seems like all the keyboards that I want, I don't know, it's been a while since I've checked because I'm like I don't need to be spending money on an expensive keyboard right now. But they're out a lot of the stuff I was kind of interested in at the time. So what we want to do is we want to eat this open array thing, and then we want to append a new token here, which is going to be token type a left bracket, and we'll just stick that in there. And then, so what is, I guess I should actually pull my grammar up. So array open, white space new line comment. Oh, huh. Like it has, I assume it has like the umlauts and stuff on it, the German layout. So we've seen this before. Where have we seen this white space comment new line, or have we not seen this before? I guess not. It's only here. So I guess we have to figure out how to parse that, or lex that. Oh, okay. Z and Y, huh. I wonder why that is. Well, of course, there's no reason for the US, the QWERTY style keyboard, which they call that because, you've got the Q, W, E, R, T, Y. Actually, there is a reason for that. It's because, at least from what I understand, it's because uh, back in the days when there were typewriters, um, they had this layout to actually slow people down because the mechanical typewriter couldn't keep up. So the QWERTY keyboard that everybody, at least in the US or typing English knows, is purposely inefficient to slow down, to prevent people from jamming up their typewriters all the time. And now here we're living with that legacy when we could theoretically type much faster, I guess. And you can get alternate layout keyboards, but it doesn't seem worth it because I don't know, that allow you to type faster, but it doesn't seem worth it because everywhere you go, it's going to be, this QWERTY keyboard. All right, so white space. Well, what's array values? So it's that white space comment new line value white space comment new line array separator, which is a comma, and then more array values. Or so basically we get an optional comma. So I guess what we kind of want to do is well, let's just try this because we're going to be in a loop here. Then Lexing's, we're going to want to eat that. We're going to want to push on this token. And then Lexine's going to be false. Otherwise, white space. So one or more of, so we're going to want to eat white space. Oh, yeah, that's a good thing. That's a good point, I mean. So we're going to want to eat that white space. I think we have eat comment. We do. So I guess we're going to eat a comment. I think we have eat new line. So I kind of want to try this. If our iterator equals a comment, Then we want to eat a comment, and we want to eat a new line. Otherwise, we want to flex a value, I guess. And that'll be iterator tokens. I guess we also have an option of hmm. Actually, we're going to want a peak character in here, I think. Oops. What did I do there? Well, I screwed something up. So if we get a comma or a hash, we want to eat the comment and then eat that new line. If we get a comma, we want to I guess we'll push that token on. That's going to be that. Else, we want to lex value. So what we want to do is I feel like we need big right because we can't have like just two commas. Maybe last here's what we'll do. We'll do last token equals no worries, Basin. So we'll do that. Then we want to say this is going to be the same thing. Although I guess we don't really care if in this case, but what we want is there won't be any token here. We want here the last token to be but what we want to do is token type comma or token type dot. It's in there. Assert false. Let's see an array value. So I think that'll catch the case where we have like two consecutive commas. And I guess so we'll just shove that. That'll get us our error. So then we'll just set that to the last token. Else, if well, this is going to be the same thing, right? The last token here should be this is going to be missing an array separator. And then we want to lex value. Now, of course, I've got to eat this character, because I always forget to eat my characters. So I think this will be our loop. So, right, if we get a value, we let me just make sure I'm tacking on everything here that I want. So at this point we know, right, the only way we know we're in here is if we have a left bracket. So then we pick that character. If we get a closed bracket, we're done. I guess we have a chance for an error here. Here, if we have a comma, well, we'd already have an error, right? Potentially. No, we just said a comma, we can have a trailing comma. Right, we can have that trailing comma. But if we don't have a value, like we just shove a comma in there, right? Well, anyway, so in this case, we just bust out. We're fine. Otherwise, we eat white space. If it's that, then we eat a comment in a new line. And then we come back through and peek the character. If it's not, right, at this point, we know we don't have any white space. But let's see. We eat the white space. We peek a character. If it's a comment in a new line, I guess we could just get a new line too, right? So I feel like we just want to start this off by eating white space. So we'll do that. This will actually bump out. Here we'll do this. We want to eat that new line. Kind of feel like we just want to put this up here. So we want to eat that character, append the token. Here we want to, if we have a comma, we want to make sure we basically have a value beforehand. Great, there's otherwise we're missing a value. Then we eat that character, we shove a token, or we shove this comma token on there, append that to the tokens. If it's a comment, we eat the comment in a new line. If it's a new line, we just eat that. And then otherwise, we are going to try and lex a value. And I guess that's it for that. And right, value just goes back to our lex value function. So let me actually, I don't know. Let's put this actually right up kind of near the top. Or I suppose we could actually put this, I don't know, this is fine, doesn't really matter. So let's see what happens now. What do we get? Oh, we get a grammar error. And now we need to define our token types. By J H H I J K L we're going to want a right bracket, LMNOP QR, and then I guess we're going to need a comma. We're missing an array value. Oh no. Why are we missing an array value? I guess we'll have to figure out what's going on. All right, so what's last token? A left bracket. Where's this? Oh, right, we need to, where do we lex a value? So we want to actually set this. Okay. Good call there. And that didn't fix anything. Now what's our last token? Still... Welcome back. All right, so what are we, am I not eating? I am eating that. Eating character. Eating the character. So we are on the thing before colors. What's our last token? Did I like just not save this or something? What's going on here? All right, well, I guess I'm gonna have to walk through this. So let's break on key last token. Oops. Well, anyway, so we've got that. We're lexing. While lexing, eat white space. That is 1. So it is not that. It is not that. It is not that. We're on what, 203? So we should be good there. And we're good there. So what do our tokens look like now? What does lex value do? I guess I just forgot how lex value works. Very confused about what's going on here. Guess we want to restart. Not sure yet. I usually see my parents because they live local. Might go to brunch with some friends. Well, brunch, but to watch a basketball game. But I haven't decided about that. Okay, we have this one. Okay. So this should be a digit, right? So we want a lexinumeric. Still have our tokens. Have a 1 again still. It is not a 0. We're going to lex this decimal. Still have what we expect for our tokens. We're going to try and eat a sign. We're going to eat some digits. So our digits, we got that 1 back. So we're at the comma, colon. That is not the case. I guess I... Oh, we're at a return? Oh. Okay, well... Number... Oh, now I screwed that up something fierce. So what's going on here? Digits... I guess I must have screwed up my integer parsing. When I implemented all this stuff. Where are we getting, So why do we think that's a tuple? Oh. Yes. This is digits. We don't care about that. Number plus equals digits. This is going to be the same thing here. So this is probably why it would help to have a real test suite in place. And that will probably happen today. Oh. But we'll see what happens here. Where else are we trying to do... Where else are we trying to be silly here? Eight. I'm probably going to want to change how I handle this too, I think. I was thinking about this off stream. Okay, there we go. So 1, 2, 3, red, yellow, green. 1, 2, 3, 4, 5. 1, 2, ABC. All strings are the same type. 0.1, 0.2, 0.5, 1, 2, 5. All right. So we're going to have to hold off on contributors until we have inline tables working. But we can do is I guess there's no reason to not just shove this in here. How about you, Basin? You got anything going on tomorrow? Another early morning of workouts? So that should work. Uh, nice. That sounds like a nice lazy weekend. You got any homework you need to get done or anything? So let's just go a little crazy here. I don't know. Oh, nice. Okay, so that all seems to work. So that was a raise. Let's go to inline tables next because we're kind of finishing out. Oh, would you have like spring break? You do anything for spring break? Oop, my coffee thing just beeped. Let me quick run away for a couple minutes, and my coffee maker just turned off. So let me just go top off my coffee. I think I blew my timer there. Looks like I did. Had a lot more coffee left in that pot than I thought I did. So I had to like quick gulp some down uh to fit it all into my cup. So what was I saying? I was like literally mid sentence, as I usually am when I stop talking. We're trying to finish out this values. So we've got strings, booleans, datetime floats, integers, all working. Unless we unless we come up on more stuff that it turns out that I broke. But we just got array, and so now we'll move on to these inline tables. So we're going to be back. Well, I guess first things first, we need an example in here. So we're going to have, I guess there's not really much point in me copying all this, but it's too late. I already did it. Oops. So that should do that. Oops. All right, so now back here in Elixir, our last option here is going to be that. We want to lex an inline table, which we probably don't have defined yet. So I have a feeling it's going to look very similar to lex array. So let's just grab that and start working off of that. But let's call it the right thing. So we want to eat that. This is going to go to a brace. This is also going to go to a brace. Oops. Deleted too many characters there. And so what is our grammar here? So inline table open. So again, we start off by eating white space. Then if we have a close, yeah, I think, yep, did I put my, I am, yep. So in this case, what is our separator here? So it's going to be missing inline table value. So, right, we eat. So what are options? Sorry, I keep inline table open. So we eat that, we eat white space. We're gonna go to key val. So and then we're supposed to have an inline table separator, which is white space. No commas allowed here. Or a new line. Here, actually, so we do want to check. Because in this case, that's not allowed. But then we'll stick that in there and we're done lexing. But then otherwise, we are going to be basically this is going to be missing separator between inline table values. This is going to be lex the key val, and then last tokens is going to be that. So let's see what that gives us. Oh, yeah, I got to create my token types. So now we have brace. and we're going to have an R brace. All right, have a good night, Bazin. Thanks for stopping in. Have a good night. Not sure yet if I'll stream tomorrow. I'd kind of like to get this done this weekend, which probably won't happen. But I don't know. If I end up not going to watch basketball, I might stream in the morning. Well, morning for me. But anyway, have a good night. Sleep well. So once again, I'm having problems here with getting this. Oh, probably because I've got the wrong... looking for the wrong token. All right. Tom, Preston Warner, X1, 2, or... So I guess what I can also do now is... Oops. Let's... We can get rid of these. Just make sure that works. Contributors. Yeah, foobar name equals Baz Cux. Baz Cux. Okay, and then this is going to be line tables. That's working. Do we have more examples here? So these are going to be... This isn't going to have any parsing implications. But... Or lexing implications, but we're going to want to test this when parsing comes around. Okay, so I think the last things we have left, right? We have now done key value. So now it is on to tables, which gives us just standard tables and array tables. So because I'm having such a productive stream and I've been sucking down all this coffee, I think the next thing I'm going to do is take a bathroom break. So that is what I will do, and I guess I'll give myself about 5 minutes on that. I feel like this stream has been more breaks than coding at this point, but there you go. Sometimes it happens. Back in a few minutes. I am back, and I just decided while I was away, I'm gonna make a makefile. So this is gonna be Python TOML parser, and then I'm gonna make debug. This is gonna be debug. Let's see what this does. Okay, dope. Probably should have done that a while ago, but there you go. This project is kind of ballooned into something maybe not larger, but just more of a production than I thought it was going to be. But part of that is because, again, I accidentally deleted my code. So this is my second time doing this. So this is just tables, right? So I guess we'll just start off here. Table. Easy enough. That might actually be all we really need to do from the parse or the lexing side of this. So let's see what happens actually when we run this. I guess I should save my files. Oh, lex table. Okay. Did not realize I had that already defined. Who's calling this? That is iterator. Oops. Iterator tokens. Oh, this isn't an expression, right? We're munching that up there. So, or not up there. Up here. Okay. So now I should just get an assertion error. All right, so that is going to table. And our options are a standard table or an array table. And our standard table is just that. So this is not the case. So we want... Oh, actually, what we do want to do is... I guess we do want to do that. So we'll do that. And then we're going to want to keep that. And if it's another one, then we're going to want to put on a double L bracket. Else, this is going to go to that. Boy. Having a hard time there. Otherwise, it's just going to be that. And then we're going to want to eat white space. Then we're going to want to lex key. Then we're going to want to eat white space. Then if peak token equals that. Then we're going to want to do tokens that append token type is going to be our bracket. Otherwise, we're missing that. So that is that. That's all we need for tables, I believe, for standard tables. And then we've got array tables, right? Well, let's just actually make sure that works. I hosed that up. Hosed that up. Peak token. Oh, I keep. Where are we? 102. Garbage. Why did we get garbage? Oh, because I did not. Gonna need to do the same thing there. And actually, yeah, all right. So we've got our table. So let's do this. That should work now. Yep. And let's just make sure this works. We get here, dog, tater man. Okay, looks like that works. Let's try these out. Uh-oh. Um, hmm. Oh, you know what we need to do? We need to. Right, so I think here in Lex key value, what are we doing this down here? I feel like what I want to do actually is throw these up here. What are options? We have a table. Do we want to do that? That. Otherwise, you just do that. This means we don't have anything. We just want to go back up to... All right. Sweet. And then let's, I guess, none of this really has any Lexing implications. So maybe I'll just come back to these later. Yeah, I guess I'll come back to that later, and I'll just finish up with array tables, I guess. And then our lecture will be more or less finished. So throw that in there. Just grab that, I suppose. Oops. Clean up on color gray there. Oops. Should hit our... Uh-oh. No, that's no good. Double L bracket. We've got boy. And then we're also going to have a double R bracket. Okay, that is on 104. And this is going to be almost literally the same logic. It's just what we want to match on. So so here's what we'll do. We'll do array table equals we'll do that. If array table then we want to do that. Otherwise, we want to do that. Then in either case, we're going to want to do that. character array table, then we want to again, we're going to want to eat that. Else assert false. This is going to be missing closing brackets, bracket for array table. What is the official array of tables? All right. Than that. I guess what we could do is okay. What's the problem here? 118? Oh. Forgot that. Somewhere I am... Oh, P character... Okay, so it looks like that is working. And I have a feeling with that, our Lexer is more or less done. And I was thinking, what was I thinking? I know what I was thinking. I know what I was thinking. I was thinking, let me just double check to see what tokens we have. Bool, comma, date, time. So I was thinking, so I have all this nasty logic down here when parsing. I think it's in decimal. Right, numeric is pretty straightforward. So I have this thing here in Lex digits where basically in certain cases of digits or we can use like an underscore as a divider between like long, well, I guess I can just show an example here. But you can do this sort of thing. That's only valid if we're actually parsing like a number, because we use at the moment the same routine for also parsing like dates and times, because those are also just basically digits. But as a result, so we pass in whether we use an underscore, and this is what broke my integer parsing or lexing at the beginning of the stream here. We're passing back the thing, and then once we figure out what sort of context we're in, we check to see if there are underscores in there, and then log like an appropriate error. well, at the moment we're not logging errors, we're just doing assertions because we're not really handling error cases. So what I think I want to do though is have this return like a token, because, well, there's some things we want our tokens to do, which it's not currently doing. We want our tokens to keep track of, and I probably should have just done this from the start, but I was impatient because, again, this is the second time I'm writing this. But we want our tokens to keep track of the line and character on which they were identified or declared or defined. So we want to keep that information, and I think we're also going to want to keep track of what basically the text that was actually consumed in creating that token. So what this means is we're in parsing these numbers, or these not these values. We're actually not going to create those tokens offhand. Because right now we're just going through and creating these. So the problem with this is it just tells us the underscore is used. We probably want to, in reporting an error, sort of indicate where that happens, and this doesn't tell us that. And Lex digits really can't know whether we're allowed to have underscores or not. And what's sort of annoying is in this case where we first start parsing numbers, we don't know either until we sort of figure out what is, okay, we've parsed a bunch of digits, what's next? Because that is basically how we determine whether we're actually lexing a time or a date or just a number. So we won't know until after we eat these digits, because again, it depends on sort of how flexible we want the lexer to be. Because we could sort of structure this where we look 3 characters ahead and see if we have a colon, or we look 5 characters ahead and see if we have the dash, because a year is only supposed to have like 4 digits, and hours are only supposed to have 2. But I feel like I want the lexer to be a little bit more flexible in that case, in case somebody just tries to enter like 3 o'clock instead of 03, so I think what I want to do is just suck out all the digits we can. Just treat underscores as like noise a little bit. And then based on what we have, then sort of validate the numbers we got based on sort of what's next. But so what was the point I was saying? Oh, so we don't necessarily know here if we can allow underscores or not. Because we could pass in like a flag here to Lex digits saying whether underscores are allowed or not, and then Lex digits could do that, and that may be something worth doing anyway. But at least in this case, we need to get back, I feel like, the actual text that was consumed by lexing digits. So then we can look in, like in this case, we can look in there and then see if there were any underscores in there. And then if so, we can handle that error here instead of in Lex digits. So the point at being Lex digits needs to return something different, and I think I want it to return a token, which means we're not necessarily, I don't think that'll get rid of some of our tokens in here. Like we're not going to have an integer or or date, time, or time. We're going to end up, basically when we get to the parsing phase of this, we're going to have the individual tokens making up these values, and then have the parser sort of construct those values from the pieces. But what we want the lexer to do is make sure if we get to parsing, we have like a valid sequence of tokens. Once we get through lexing, we want if we get through lexing and there's no errors, then we want the parser to know that there's at least syntactically valid TOML, and then we have to sort of apply these rules here that the lexer can't really figure out about redefining keys, stuff like that. That's pretty much most of it. But so then we'll have the lexer sort of put together these values, and then also check the rules about redefinition and stuff. So all that babbling to mean that I want to change what flex digits it's doing. And I suppose to sort of drive this, I want to, do we have integer? Where are our integers? Here. Let's turn that to true. So start there. Let's just make sure that's working. That all appears to be working. So what we're going to have is we're going to have a new token here called digits. And then flex digits. So what we'll do, we're going to get rid of this. Well, actually, there's a couple things we need to do. Well, let's just do this for now. And I'm thinking, we can probably handle that here. We can keep this error here, I think. Yeah, so what we'll do is kind of if digits, then we want to return a token with token type digits, and the value is going to be digits. Else, and then in this case, like, we'll return none. So what we're going to do here, this is going to go to something like that. Well, I guess we don't want to do that. We don't, well, I suppose, I don't know, I suppose we could just, guess that's fine. I guess that's fine. It's not necessarily probably the most efficient way to do that. But whatever. This is going to be the same thing. We're also redoing lex digits. Not in digit stat. Oh, not value. Well, so see, right now our tokens are not capturing the information that we want them to. So I guess we need to fix that first. So where are we here? We're here. So let's just do that. So our token, so in order to do this, what we're going to do is self.line equals 1. Self.character. So for error reporting, I think we want to start this off at 1. So we'll do that. Where is our token? Our token is going to be type. We'll call this the lexeme, and then we'll do line and car, I guess. I don't know. But I really don't like spelling lexeme. So now when we do that, we want line equals car equals that. This is going to be type. So let's do that. Now everywhere that yeah, so now what we want to do is as we eat. So what are we doing on eat new line? Actually, let's do def e. Does everything go? Hey, Thumbstro. How are you? Welcome. So let's do car iterator. Oh, so let's do this. Car equals expected. So what we want to do here is if car equals a new line, then we want to iterator dot line plus equals 1, iterator dot, what did I call it? Car equals 1, otherwise iterator dot car plus equals 1. I did call it car. Welcome to the stream. How are you? Unless you rolled out already. So, I'm doing well. So we broke that somehow. Oh, this is expected as none. I suppose I should have just kept this. Well, that was not what I want to do. Let's do that. Okay, so we're still missing arguments to that. So now what we want to do is, I think, so since this is in parse, so TOML, this is TOML here. It's basically like, I mean, this is kind of like a configuration file syntax. I mean, it doesn't need to be configuration files, but I guess that's typically what it's used for. But the whole point of TOML is when you parse this, it results in yeah, it's a configuration file format, and then it's basically maps to like a table of values. So in this case, it's going to read in this file and then return like a Python dictionary mapping little keys to values. So that was basically it. But then there's a grammar here on what a TOML file looks like and what the different values are that it kind of supports. And then so right now I'm just working on the lexer. So what this is doing is it's literally just iterating through all the characters in the file and then seeing what we have. And it's creating these tokens, telling us basically the different, I guess what you want to call it, like well, I guess technically to be called like lexemes, but basically the different pieces of grammar in the file. And the lexer is going to make sure, like if we get through lexeme and there's no errors, then we know we have a syntactically valid TOML file. But then there's also additional rules here that says like you can't redefine, like name has already been defined here, so you can't redefine it down here. So there's different rules like this here in the spec. So there's going to be a parsing phase where we get all these tokens back. It's just going to be a list of tokens, and then we start walking through the list of tokens and then building up basically the Python dictionary and converting these to Python values, whatever we find, and then checking these additional rules. So that is what I am working on. And it's been a little bit of a process. I've been I started reading a book called Crafting Interpreters, but which isn't really interpreter, but it kind of tells you how to write a lexer and a parser and stuff. This is it's ended up being a bit of a learning. I mean, that's why you do something like this, to learn, I suppose. So, but what I'm trying to say is writing a lexer for TOML has been much more difficult than trying to write a lexer, the lexer that was in that Crafting Interpreters book. But I guess that's not much of a surprise. When you try and write real stuff, it ends up being more complicated than the examples they have in a book. So what I'm trying to do now is I basically have everything lex, like this file here is the actual grammar, grammar of the TOML, and this is just linked to from the bottom of the documentation here. So this tells us what the valid grammar is. But what I'm doing now is I want to add some more information to my tokens so that I can have a little bit better error reporting. So I want to, probably should have done this from the start, but I just dove right in. But I want to keep track of the text that we actually consumed in making this token, and then the line and the character that like the token started on. So I don't know, if you hang out long enough and I don't bang my head against the wall too often, you'll probably see the payoff on this as I start to implement more error messages. And so what I think I may want to do, I think we're still back to the point where I'm not passing enough arguments to token. So I'm just going to make a helper function down here. We're going to take the iterator, the type, and then the value. Wondering if I should. I think we're always setting a value now, which I guess I'll just, oops. So I guess I'll just make that. Actually, you know what? My iterator is not capturing everything I want. So we want start to be that, and we want current, because we want to keep track of like the stream of text that we're kind of eating so far. So what we want to do is our lexeme is going to equal the iterator TOML and then the iterator start to the iterator current, I believe, and that should pull out the substring. And then we're going to want to return a new token with what's so it's going to be the type, value, the lexeme. Oh, I don't want to do this yet. I guess I got to think about this. You know what? I need to split this out. So we have start line, start car, and then we're going to want current line and current car. That's what we're going to want to do. We're going to want to, so we pull off this lexeme, and then we want the start line, the start character, and then what we'll just do a helper function here called advance, and then we'll return the result. And this advance will be responsible for setting the line, and then oh no worries. I just since I'm streaming, I kind of just try and talk through what I'm doing as opposed to just sitting here quietly typing. So mostly I'm talking to myself, but yeah, if you have a question or anything, or I ask a question you want to answer, feel free to jump in. But that way I figure if anybody's kind of paying attention and not just having me on as like background noise or ASMR or whatever, they'll have some clue what I'm doing instead of just watching me type. So unless I have some parsing errors here, so I'll just have to get through my oh, it's current. 807. I guess what I could do is oh, you know what I want to do? I want to change this to a head. So this is going to be current. Current. Don't know why that's. So what was I searching on? Pause. That's it. So now I have to figure out everywhere that I am. And replace that with that, I guess. token is missing. Oh, that's not what I wanted to do. I am, yeah. So we need to fix that a little bit to iterator. Let's see what that does for us. Yeah, well, oh, well, I didn't want to change the one where we're actually instantiating the class. I got through about the first 3 chapters of, like, the user manual. Oh. And got comfortable enough where I'm like, okay, I know how to use it now. But, like, there's some other streamers. Well, I guess specifically, what's his name? The Primogen. I don't know if you ever watched him, but he's like knows all this fancy Neovim foo. I'm nowhere near. I am nowhere near as versed at Neovim as he is. So I guess that's kind of working. There's no real way to tell, I suppose. I kind of feel like what we want to do is some of this eat stuff. Maybe we don't. Where are we calling this eat car whites? Because now that I'm thinking about this, we're going to advance past our character and we try and create a token off of that. What do we do with flex value? Do we start off by eating? No, we don't. How many times are we using this? I don't know what I ended up matching on there. Only 3 times. So I think we probably don't actually need to... Oh, we're only... And one of that is a definition. So here's what we're going to do. We are going to eat white space. If then we're going to want to do that. Otherwise, you've got some sort of error there, and then basically we're going to want to eat white space again. Okay, so here again, we're going to eat white space. Then while when do I put, oops. We're going to want to do that, eat white space. We need to eat these characters, though. I keep forgetting to eat characters. We need to eat the character. Append that. I think we'll be okay. So one thing I guess I could do just to check this out is instead of doing that, let's just print the token out itself and see what we're getting here. this may not have been the greatest example, but we have line 1, character 1, int, line 1, character 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. Some of this eat white space, do we always want to? I think we may always want to advance on white space. Let's do that. So now we've got our equal sign at 6, right? 1, 2, 3, 4, 5, 6. Integer is at 8. Or no, we've got, oh yeah, that is right. 6, 7, 8. Then we've got 1, 2, 3, 4, well, 8, 9, 10, and then that new line is at the end there. We just have the 1, I think. So here for comment, and I only know this because this is the second time I'm doing this. Instead of advancing, we want to set the iterator dot current line equals because in this case, since comments like you can't, like comments have to consume the rest of the line, and we don't actually keep that around. Let's say there's an error here. We do keep the new line token because that's like a expression separator. We're basically going to want the token following this new line token after the comment to appear like it happened here. So we're going to want to basically just pretend like the comment doesn't exist. Thanks for stopping in, Femstro. Have a good, I'm not sure where you are, but have a good night or day or morning. And yeah, thanks so much for stopping in. But I think, let's just check this last one here. What is this? Bin 1, line 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then we just grabbed that. Actually, one thing I want to check. Wait, do we have integers with underscore? We do. Int 6. Oh, we're not showing the lexeme. That's right. Where are we? So let us just look at the see what the lexeme is at the moment. Well, that's not right. I guess so. I guess we want to do that, and then we want to advance. Okay, that looks a little better. That looks a little better. What happens if instead of okay, that looks a little better too. So here we have the digits, and here we've got the text that we actually consumed to do that. So everything seems to be looking good there. So now what was I saying? We want um we want this lex digits to return a token now. So basically what we were doing before. So if digits, and it's going to be digits. Otherwise, result equals none. And we'll return that. So that's going to break a bunch of places. So here we're going to have so now everywhere where we have lex digits oops. So we could get none back here. And maybe what I do here is I'll just pass that in and do the validation and date and time. I kind of like that. But what happens here? I guess what we'll do is we should shove those on there, right? So tokens that, so if we have digits, well, that's going to be else, because all of this, if digits, then we're going to append that. Actually, we want to, this is going to be there. Oh, no, this is, right, because we're saying lex digits can handle that. Right, this is handling, yeah, no digits. So if we get digits back, then anyway, this is going to go, oops, basically that. we're not going to have number here anymore. And in fact, this is going to go back to lex sign. Was it eat sign? Is sign. Okay, so what we'll do is we want the tokens here. We're going to append. We're going to want to eat that. Can't forget to eat we're going to have the iterator, we're going to have token type plus, and we're going to have we're going to have, I guess this is going to be car, because I don't think we need to return this result anymore. This is just going to go to car. This is going to go to minus. And I wonder, so we need to figure out where we're all, I guess we need to figure out how I'm using this. So this is going to go to like sign iterator tokens. Same thing here. Same thing there. Same thing. What are we doing with sign here, right? Okay. Same thing there. Move that out of the let's put that down here. Okay, and then we still have lex digits. Where are we now? Digits. That. Then we're going to have digits here. Wonder if we just should have lex digits slap that on there. Pass in the tokens. Probably not, actually. So this is going to go same sort of thing here. Token type, I guess this will be E. And then we'll just have that E and a lex sign. Wait a second. This is I guess that's probably fine in this case. So let's call this exponent. And we don't need this anymore. I guess, yeah, we don't need this time to float. I guess I could maybe just throw this into its own function. I don't know if there's much point to that, but I don't know. This will be iterator, tokens, digits. So let's just integer just leave that the way it is. Then we're gonna oops. I don't know. It doesn't really matter. It's probably stupid renaming that. Oops. So let's see here. If we have digits, then we want to make sure we have no leading 0. Then we append that. One thing. So I guess we do actually want to know if we lux a sign, right? Probably need to handle that. Result equals true. Same thing, result equals true. Don't know why I have that there. And then, oh, return result. So x sign equals what is it, state? Can't have a sign. Same thing here. Time can't have a sign. And we're going to want to pull off whatever the previous token, which shouldn't be a problem. Where else do we use this? That's fine. That's fine. That's fine. Okay. So I feel like I still have more Lex digits I need to do, but I'm also going to need to take a little break here. So I will take a little bit longer one this time. But I will be back in a few minutes. Let me just set my own timer here. All right, back in a few. Well, I blew my timer. Oh well. That's what happens. Let me make sure I am back up, and this thing keeps crawling up the screen. But I guess back at it. Uh, yeah, yeah. I'm thinking. I'm wondering if I actually want Lex digits to return token. I'm beginning to think I don't. Not sure. Guess that doesn't really matter. Because, right, I guess my thinking is right, where we're lexing like a binary or whatever, we're immediately like discarding. Oh, and this isn't even correct. We're immediately like discarding that. Um, so I don't think I do. I don't think I do. So this is going to change to uh, not digits. We're going to do that and then just return the digits. So this is going to go to that. Right. This is going to go to that. And actually, so this is now just a string. So that, probably just put that back up there. I think I'm going to call this whole and then digits. So then let's see what we have here. We check to see if we have a period. If we do, we eat it, make a token out of it. Then we like digits again. This is going to be, we'll call this fraction. We're going to call this, go back to calling that E. We're going to lex a sign, and then this is going to be token. This will be exponents, and then digits. So where else are we? We also kind of need to sort this out for date and time. What? we're not doing anything with this valid, are we? And actually, what is is there not like a oops, like a not an infinity literal? Let me see what the tubes has to say about anything. Oh. So let's see. So I guess we want to import that. So what are we? Like a special float. So this is going to be math.infinity. This is going to be not a number. And then that goes away. So we don't need this valid anymore. So then what we want to do is if here this is going to be tokens that append token type is going to be our oh well, we need the iterator there, and it's going to be our year, I guess. This is going to be dash month is going to be basically all going to be the same. Year, month, month. This is going to go to another dash. And then well, I guess this is going to be the same thing, except this is going to get a day. Oops. I guess we kind of need to do the same thing here, don't we? Because I believe I said we're going to do all this in here. So that should handle, oops, that. Then we're going to want another token here. This is going to be time, I guess. Guess we'll just put a empty one in there. So, and then we're going to pass in hour. And here, we don't need this date anymore. Well, so if basically if hour, then up an hour, otherwise it's going to be valid underscore used in time. And this is going to be tokens that append. This is going to be hour, hour. Oh, I guess we don't actually know. What are we doing here? I guess we actually got to peek this because we can get to Lex time through Lex state here, and we don't know that we have this. So this is going to be colon false, assert false, scene separator between hour and minutes. This kind of thing here. Actually, I guess I'll just yank this. This is going to be the, oh, we do need to eat that. That goes to that. And then, okay, so then if, oops, tokens that append. It's going to be a token type period, and then that if fraction, then oops. I guess this all goes here. And then we're going to append what do we have? Fraction, I guess. Okay, and then oh, I guess this goes back to we can handle this back up in date now. So let's yank that. So if, where are we here? This goes to here. This is going to go to I think what I decided is I'm just going to synthesize as Zulu, because this goes to like token type plus plus. We're gonna have the hour colon minute. Oops. Hour colon minute. That's going to go to 0. That's going to go to that. That's going to go to 0. So we just synthesize that. We're going to Lex assign. We're going to do that. So otherwise we're going to our the iterator I need the oh, this is interesting. Guess that doesn't Guess doesn't really matter. Okay, so then I think all of this goes away. Yeah, all that goes away. As does that. So let me just take a look through this real quick. Good year. We slap a year token on there. Slap a dash. Try and Lex months, so we slap the months in there. Slap another dash in there. Same thing with the day. We don't need that. Then we look to see if we have a time separator. Do we eat that character? And slap a time token on, then I guess we gotta Lex the digits, or Lex the hour, and then we just pass that into Lex time. Then we check to see if we have a time zone offset. So if it's in Z, we just synthesize this plus, we synthesize this offset time, which is just going to be plus 0, 0. Otherwise, if we have an actual sign, we're going to do all that manually. So we're going to get the hours, the colon, and the minute. So, and then down here in Lex time, we validate our hour, although we're not quite where we need to be with that. Try and Lex a colon, try and Lex minutes, Lex another colon, try and lex seconds, and look to see if we have a fraction. We eat that. We append that. Oh, that period needs to be. Okay, well, somewhere I did not close something. Where would that be? Well, I guess when oh, here, it's like there. And somewhere else. Probably everywhere I copied that. Right here. Okay. So then, yeah, we slap a period on there. Okay. Then we try and lex fraction. We pull up the length. If it's less than 6, we take that out to microseconds, because that is the value that Python supports. Otherwise, we truncate it, and then we slap that fraction on there. So I have kind of no expectation that this is going to work. That was not... this is going to go to if digits, and then digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so let's see what happens here. Oh yeah, I gotta define all my tokens. So what did we add? We added minus. I think these go away. That goes away. But we're going to add plus minus. Go through here. We need whole. Those all appear to be lexing. Try floats here. Fraction. What else do we need? E. Exponent. That appears to be working. Let's see. Float 8. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Line 14, character 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that appears to be working. Don't want to mess around with invalid floats, but let's try that. So we don't need that number. Okay. Oops. I guess flex sign. Where are we? 485. Oh, assert. Where are we here? Not in digits. Oh, I was wondering if right, I think in Lex, didn't I say I was going to handle that in, where are we? Def, Lex, date. Yeah, so that's handled in there, and that's handled in there, I believe. Yeah. Now what do we have? Year. Hey, Splev. Thanks. Appreciate that. Year, I guess we need month. We need day. Hope you're doing well. If you haven't bugged out already. Dash. Argument of type int. Oh, did not mean to do that. Our we need minutes. We're gonna need second. Colon. I guess that's that. I guess that looks okay. This will probably be okay. That looks okay too. So I think that may be all I wanted to do with that. I think so. I think with that, the Lexer may be more or less done. I think it may be done. Probably gotta tighten up the error handling. But at this point, we can maybe start throwing that in as we start parsing. Clear out some of these extra lines here. And presumably, as we start to test things, we'll start to hit these assertions, and what we can do is start putting actual error messages in there. Because I think we now have everything in place that we'll need for that. Yeah. So I feel like at the moment, I'm fairly happy with how this has turned out. I guess we'll see if this is doing what we want it to do as we start to write the parser. I guess I'll commit that. Just quit out of here. Oh yeah, I had my handy little make file there. Guess I don't really need to all right. So that's done. That is done. Ugh. Feel like it's almost kind of time for another break, except I've been taking so many breaks. I think I will have a pretzel, though. Might be time for a beverage break. I'm mildly curious to see, with everything I've done with the lecture here, what kind of implications that has for the parser. What not too much code in there. A good part of that is, well, not a good part, but oh, okay. So this file's going to go away. Okay. Oop. So maybe the first thing here is my experience writing the parser the last time was things kind of started to get a little complex, where I was like breaking things. So at this point, I think I'm gonna pull this stuff out and do like a test suite. So um, actually, I'm wondering, I ever guess I did put that there. So I think it's test case. Let's see here. Looks like it. Well, actually, yeah, test case. So let's see here. Boy, okay. Guess I should have just deleted that, but oh well. So I think that should just comment all that out. Let's see what's going on here. Uh-oh. What if I do this? Oops. Okay, so that's good. But so what that means is it looks like we actually have tests running. So TOML is going to be that. I kind of suppose probably going to have to step back through this. We're going to have our actual is going to be, well, I guess we're going to want to import this. Expected, so we're going to expect a key value and another, this is not a comment. And then where are our assertions here? Excuse me. Although hopefully you didn't hear that. Well, it looks like I'm unmuted now anyway. I would have thought they would have just right here what the available assertions are. So we want assert. Well, we want that, right? And so all right, so cannot import name parse TOML. Yep, that makes sense. So how do I want to structure this? I guess what I may want to do is let's see here. Probably I can just get rid of that. So what do I have open now? So let's get rid of that. We have our test. So let's get rid of main. And get rid of that main. And I guess so grab our license header here. So I guess we'll just define this in here. We kind of want, I guess, just something like that, I think. Oops. Okay. That is as expected. Actually, this is not true. What we want... we're going to want the lexer in there. So what do we want lex TOML to return? So here, let's do lex errors equals lex TOML. If lexed, then well, parse will give us back, I guess, probably result errors equals parse TOML. This is going to be tokens, actually. Let's just call that tokens. So we'll do this. Result equals none. If we have tokens, then we'll get that back, and then we will return result errors. So I think I like that. So we still don't have our right, we don't have cannot import name parse TOML. Yep. So too many values to unpack. That's right, because we're So I guess what we're going to want to do here is on our iterator here, we're also going to want to now put this error log in here. So in Lex, what we'll do is so I guess that'll actually change the logic here. More like if errors, or if not errors. So yeah, let's try that out for size. Okay, and we got nothing back, which is what we expected. Oh, I just realized what I forgot in Elixir. What we want to do is we're going to shove one more token on here. And I guess we'll just make that an empty string. Element, no, end of file auto. How's my alphabet these days? H I K L M S T O. Yep, okay. Looks like I still know my alphabet. Oops. Okay, so we are still getting nothing. So I guess back to the grammar for the moment. So where are we here? Oh, and also we can take in we can take out date time here. We'll need that in the parser eventually. So I might as well just stick it in there. Okay, so well, we're going to need another iterator. I guess, you know what, I like having the errors in here too, because we're going to be passing this, otherwise it's going to be something like return result. No. We're probably going to need some sort of like TOML state, because things start to get a little tricky in there as we get to, so let's just set that up now. What we'll do is we'll have, I don't know, should I call it result? Or the root? Let's just, I don't know, root table maybe? I don't know. Or I guess I could maybe call this table state. So let's do that. I like that. All right, so what we're going to have here, this is going to go to state.root. So we're going to set up our iterator. I call this token iterator. And then our state is going to equal our table state. And then, so TOML so we're going to want to parse an expression. Take the iterator and state, I guess. And I feel like here's what we'll do. While parsing, then here's what we'll do. While parsing, we want to parse the expression. Parsing equals e token iterator new line. So then we want to assert basically that, I guess. So we'll have some errors. Parse expression is not defined. Yep. Iterator state. It's passed for now. Let's get the rest of this working. E token is not defined. So I'm wondering if I want a peak token. Feel like I probably do. Yeah. So what we'll do is peak token iterator, or actually result is going to be equals type. Or that's just going to be result. Or if result, then we actually want to advance the iterator then. We're going to need to find this peak token. I guess we should make some assertions about actually, we can just do that here. Actually, let's do this. Because I think we should never, with that end of file in there, we should never get up to the length. So def so now I suspect yeah, we're gonna need to import tokens. which means we're going to need to token that high. Actually, we're going to need to have to pull all this enum stuff in here too. That comes out of here. We're going to need to import I have a feeling I did this wrong in parser. Let's see what happens there. Where can't we input Lexer line 8? Why can't we do that? Oh, because I did not change my names here. That is why. Peak token is not defined. Oh, what did I not? Oh. Yes, we want to peak it, not peak it. Well, yes, because we're not doing anything in parse expression at the moment, are we? So yeah, let's just take this out for a brief second. Our test should still fail. Yeah. So I guess now what we're saying is token equals peak token iterator. Token.type equals token type key. Then we're going to parse key val lf token type equals token type L bracket. We're going to parse the table. Oops. Token we're going to parse an array table. Otherwise, we don't do anything. Because, right, we could just have a new line. Because this ends up as new lines. So that is that. Now, we need to find key val. So I think everything, we did take that assertion out. So key val, we're going to want to token iterator token type key token iterator token type dot equal, and then value equals token iterator. I guess, yeah. So type equals none. So this is not doing at all what we want it to do. So we want a peak token. We want to assert that type is none, or result.type no. Do we want an assertion here? I feel like we do. I feel like we do. Right? Or result that type equals type, and then we want to just return the result. Well, we want to do that. So now well, actually, I guess we don't want to eat that token. We want to parse a value. Don't think we need to state there though. So now I think we should get as far as having tokens is not defined. Oh yeah, state. Okay, so parse value. So what are our options for and actually what is the test we're doing right now? We just need a string. I'm thinking so what do we do up here? We get this value back, and then what we want to do is we want to do state dot root key dot value equals value. I guess that's what we're saying. Boo. E token new line. So I guess, what do we want to do for tests now? I guess or debug, I mean, unit test, maybe that? How do we feel about that? Well, poo. Okay. Well, either way, we need to break on source, TOML parser, what are we in? 73. I feel like this should have, stop the debugger where the assertion, well, I guess not if, Unit test is catching it. I guess we gotta restart and run. What's type? And what's result? So it is a new line. So this must not be. Oh, that's right. I know what's going on here. We peak token. Parsing. Do we want to eat that? That's what we want to do. Oh, parsing equals peak token. I am struggling here, apparently. Where are we at? 23? I suspect here in parts value, we're not, yeah. Not eating that. So that failed. Oh, yeah. How do we do, so isn't there a way to do like subtests? Um, no, so, okay. Okay, so what we want to do is we're going to have table and errors, I guess. And this is what, with self.subtest. Table expected, and we're going to want to do I guess we're going to do errors and none. Doesn't? Oh, sub test. Okay. Progress of some sort. Progress of some sort. Okay, back to the test. Let's get one more going here. Let's actually pull up, what am I looking for? This, I guess. So I guess we just have, this is gonna kind of be, let's do, let's just kind of shut this down now. Errors equals, in fact, we should either have table or errors, right? So we have, what is our, we have setup. So here's what we'll do. Now here's what I kind of hate about this. So here's what we'll do. We'll actually double underscore this. Table equals none. And then self-assert result, we're going to have TOML. I guess we'll just take the TOML in here. And we will pull out this essentially. Assert table, self table, and then this is going to be self dot errors. So we'll do that. And so, well, what I didn't want to do was just delete all that. So we'll do self.table equals this. That was a mistake. And we'll do that. And then for this, we'll do that, I guess. I don't know, parse table. I don't know, resulting TOML. TOML errors, I guess. I don't know. Guess we'll see what happens when something fails. So assert result, 2 were given. Yeah, we need self, don't we? Okay, those pass. Sweet. Now we want this. Test invalid. Key value. Oops, what'd I do? And so let's just set result here. See what we get. Actually, what we're going to do is we're going to hit an assertion error. Or we're just going to have invalid syntax. So invalid / missing value. So I guess errors is going to be I guess I need to think a little bit more about how to handle errors, and I think what I want to do is set that up as a class. Um, so I think I will take a beverage break though, and pick up on that when I come back. So short break here. Get my Saturday night rolling. How have I been going? I feel like I've been making good progress on this one, although I shouldn't speak too soon. All right, back in a few minutes. Okay. Looks like I am back. All right. So, oh yeah, errors. Errors, errors, errors. Okay, so I think I'm just going to do... let's do the lecture here. So... What do we want? Maybe the token? Well, I guess I need to figure out what I want. So what do I think I want here? I think I probably want errors to be we're gonna have like line 1, character 1, or no, line, that'll be character 1, 2, 3, 4, 5, 6, character 7. missing or invalid value for key. I feel like is kind of what we want that. And then line 2, character 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, I guess that's going to be. We want that to be something like um, well, I had in the previous version of my Elixir or parser, the error message was something like expected new line after expression. So let's just try that. For some reason I didn't like that, but let's just see where this goes. So let's just do that for now. Now back here in Elixir, where is this we're hitting? So let's do invalid or missing value. We're going to need to put the iterator in there. And so let's do, we're going to stick our errors down here. What did I call this? Invalid missing value. Is that what I called it? Invalid. Let's just get obnoxious here. So we want the message to be something like, well, I guess we know what we want our message to be, right? Missing or invalid value for key. Let's just make that missing or invalid value. I guess we'll put a period at the end. And then we're going to want to do iterator.errors.append. We're going to want an error. I guess I'm not sure if we want, do we want to advance? Not sure. I guess we'll figure that out. So we'll do iterator. Current line, current pause, and message, I guess. And actually, you know what? I feel like I'm going to want that as a... I don't know. I feel like I'm going to want this as a... Well, I suppose I should wait. Because I don't know what I want that to be. But, yeah. So, I guess what we're saying is we want the line to position it in the message. So now we need to... From... So self line, line position message, self.line equals line. I don't know, I guess we should be consistent and call that car. And let's do a rep run this. I don't know what oops. Don't know what I did there. Okay, so we want to say maybe just error on... Well, maybe we want two different things. We want a string, and we want error at. And then here we'll just do guess we'll do something like that. So now what happens? Now what do we get? Where is that in? Oh, that's going to be an elixir, isn't it? Where are we? 811. Circ false. Okay, that's in 25. So we want to resync. I feel like I'll put that error in resync, maybe? I don't know. No, probably not. So we'll do expected new line. And we want to re-synchronize. This is going to be... What did I say? Expected new line after expression. And I guess... iterator.errors.append error that current line. So we'll do so see we have resynchronize. We need resynchronize. So where do we want to do that? I guess we'll do that, or maybe where do we have advance? And what do we have? We have, I think we have eat new line. Yeah, well, not eat new line iterator, eat the character. And we want advance. Resync, resynchronize. All right. Resync, well there now I'm getting it. Oh, iterator. All right. So I guess what we want to do is do those errors. How you doing, MKB? Yeah, I don't know. I guess I always have usually if I'm writing to another API or something, I usually have the docs pulled up on me instead of relying on the IntelliSense. But I mean, it bites me sometimes, like when I'm trying to figure out what I just named my function. I don't know. There's a bunch of videos about setting up NeoVim to have like a language server, and so you can have IntelliSense or whatever. But I've just been too lazy to do it, so it's almost more laziness than than anything. But I'm doing well. I'm doing well. Slow Saturday, so I'm doing some coding. Guess you're up in the middle of the night again? Oops. So I guess what I want to do is maybe define a comparison operator here. I'm gonna have to look that up. Let's go over here. Yeah. Well, that's one of the annoying things about interpreted languages is because if you misspell something, you're not going to hit it until you try and execute that code. So that's kind of one of the nice things about compiled languages. So it's other. Um, so let's do result equals false. The type other is type self, maybe? I don't know. Seems reasonable to be. Result equals self.line equals other.line. And self.car equals other.car. And self.message equals other.message. Turn result, I guess. Oh, yeah. I really do want to like that, but I feel like it just gets so like it's very messy. Because especially if you start wanting to do generics, you have to import that typing library, and that actually like adds all this. I don't know. I suppose if you like make a wheel or right, you run off a compiled version of it, because right, Python compiles to like an object file or something. Uh, it probably removes all that, but I don't know, it just adds a bunch of ugliness to the language, I feel like, because it's kind of tacked on afterwards. You know what I'm saying? Yeah. And I also feel like a lot of static analyzers have a problem with it. So it's kind of like, I mean, I get it, right? There's these projects with all these thousands of lines of code or tons of thousands of Python, and nobody knows what any of it's doing because it's all dynamic. But it's like, I don't know. At that point, just use a statically typed language. Of course, then you're talking about a rewrite, right? So I don't know. Oh, now we need to actually make these errors. So from TOML parser dot error import error. So I guess what we want this to be is error 17 2. Oops. So let's see what that gives us. Oh, it gives us gives us that. All right. Yeah. Well, I mean, I think right, your thought is being borne out by the fact that PHP is adding type hints, and people are writing PHP static analyzers, and Python now is adding these type hints, and people are writing Python static analyzers, and then Microsoft made TypeScript so that people knew what their JavaScript was doing. So, I mean, I don't think you're wrong. Yeah. I mean, I almost think the fact that all these dynamic languages are now adding these static analysis type hinting capabilities sort of, we know who won that argument, so to speak. So I think you're right to think that. And it's like, as you really start to do complicated code, like this isn't a very hard or big project. It might be 2,000 lines of code, but yeah, as you start to get into complex projects, having a compiler and type safety and everything, or static analysis, can really kind of help you sort stuff out. Because it's like if you want to see where something's used, right? You just change the name of it and see what breaks in what breaks in the compiler, and there you have your answer. Yeah, well, that is the there's a book, Crafting Interpreters, which I've kind of been reading sort of as like an introduction to this, to me writing this. I kind of had it on my reading list for a while. Now that I wanted to write this parser, I started reading that book. But yeah, if you sort of look to see how it works, and I don't know, it goes into a lot. I've it's like two parts. First part, you write like a Java interpreter, and then the second part, you rewrite it in C, and you actually like, well, kind of compile it, or when you lex it or whatever, you turn it into like a bytecode, and then you like interpret the bytecode. But when you start to write that, you kind of just see how inefficient interpreted languages are, you know? So, I mean, they're fine for just kind of little tools, I guess. But yeah, it seems like if you want to do real work, you probably want it compiled. I don't know. But anyway, it's an interesting book. It's a very cool book. I want to get on to part two where I haven't gotten to the part where you're writing like writing your own bytecode and then a bytecode interpreter. I mean, everything that I've written so far looks very much like what's going on in that book, to be honest with you. So we want to test bare keys now. So we're going to have that. We're going to have, what do we have? Self table equals key value bare key value bare key value and 1, 2, 3, 4 value. And self sort result TOML. Yeah, but I mean I agree. Yeah, if you're just writing like a simple tool or something, Python's fine. I feel you're right. That's kind of the point of it, I suppose. So I guess I should just make sure I'm keeping up with my examples here. Bare keys, quoted keys, because I skipped some of this because it didn't really have any impact on the lexer. So so we want table to be equal 127.0.0.1 equals value character encoding equals value. What have you been doing with your weekend? Anything interesting? Oh, I forgot this one. Okay, so that runs. So that was what? Quoted keys. Bare keys. So I may have to split this out into 3 tests. So we're going to want to do empty let's do that. Let's do that. This is going to be the same for these. And then this is going to be so this is going to be what? 1, 1, Missing key, I guess. Let's see what we get. Probably an assertion error. Oh, or... Alright. Yeah. Oh, nice. That is a... I don't know, what's the weather like over there? It's been snowing the last couple days here, so... Not that you couldn't walk in that, but it's been a good weekend. I don't know. Today was kind of a, I shouldn't say a loss, but went out with some friends last night. Here in Chicago, like in the middle of winter, they do, well, they call it a restaurant week, but it's 2 weeks. But basically, a lot of the restaurants here in the city, they do, so it's like a thing where there's like a $25 lunch or $42 dinner, or there's also like a $59 dinner option. But all these restaurants will have these meals at these price points and sort of put together a menu that's supposed to like highlight, their menu, I guess. So it's kind of to get people out, when it's snowing like this. So I went out to a steakhouse last night and had a pretty nice time. And then went out a little bit after that. Feel like I should have gotten an assertion error. Okay, so that is cold. 3 degrees is cold, right? You might actually be colder than us. I don't know. I don't know my Celsius, so that's well, that's above freezing, right? Yeah, duh, because 0 is freezing. So we're below freezing here. No, we're colder than you. We're like, I don't know. I suppose I gotta pull out my all right. So you're 3. Okay. And what are we right now? Um uh feel like it should be cooler than that, but yeah, we're 30. So we're below freezing. So can I type that way? Okay. So there you go. But I felt like it was down in the 20s today. Like I thought they were talking like 25. So there we go. That's what we are. And I can see all the snow outside my window. It's pretty hazy. Flakes in the air, as they say. So what's going on here? Oh, I suppose, well, actually, this is another dumb thing about Python. Oh no, I named it, so what's going on? So get an empty table and we got, oh, because I have that commented out. There we go. Yeah, it's always nice when it's snowing And it's even nice after it's fallen, just not when trying to cross streets, because like we have snow plows that go around and throw a bunch of salt down, so it's like the corners turn into like lakes of slush. So trying to get around those is not fun. But if you can get away from like all the slush in the streets and the curbs underwater, like walking around in a park with a bunch of snow, that's always nice. Uh, so what do we have here? Um, we have invalid or I don't know. Let's just do that, I guess. Missing or invalid key. Ugh. Never fails to put the space on the wrong side. All right. Yeah, I'll be here. All right. Dotted keys. Here's where we start to get into a little logic now. So expect this to be name orange. And then we expect physical to be another table. Your color is orange. And shape is round. And then we have site equals google.com is true. And then we have fruits name equals banana. Color equals yellow, and then flavor equals banana. I have 3 equals 14159 pi. TOML. Okay. So there we should get oh, huh. Oh, I know, right, because we're not handling, right, we're not doing this correctly. So, so I guess what we want to do is we want to say, oops, this is all this, right? I think. What samples do we have, or what tests name. So we got name, physical site, and then we got this fruit. And then we just jump down to here. Okay, so we're going to want to come back and sort some of this out, but in the meantime, so we're going to say active, or we'll just do table equals state dot root at the moment. Key equals token. Well, peak token iterator.type equals token type dot equal. We want to say table key dot value equals a new table. What we want to eat, we want to eat that token. And we want table to be equal to table. Here's what we'll do. We'll do and then key equals eat token, basically this. Yeah. So all of this is failing now. I really broke that something fierce. Oh, well, I do want... Not that this will fix anything, but so what's going on here? 67. Why do we not think we have... So this is failing on everything now, right? 67, 67, 67. So I guess what we'll do here is and what we'll do is we'll on 61. Why didn't that what's going on here? Okay. Source, TOML, Lexer, 61, right? Oh, I'm in the parser. All right. All right, so what do we have? We have that. So we have that. Oh, because I'm an idiot. That's why. So we have a failure somewhere. Bool. Oh, okay. Where's this? 81? I guess in this case, we're going to want to just return, right? Dude, return. All right. Let me just sort this out real quick. So that should do that. Now what? So we're expecting a 3. Having a hard time figuring out. So we actually got 3 with an empty string. Why did that happen? Oh, because we want to do that. And I think I want to do, this hurting my head a little bit, def cert. I think I want to do, I just want to swap these around. Table. Errors. So expected that. Oh, yeah. All right, so here's what we want to do. Eat that token. So if key in table, then, or I guess what we really want to do is we want to do if key not in table, table key dot value to be precise, key dot value equals a new empty table. Value is going to, and then actually we're just going to set table to that. Guess that's what we're doing. All right. Cool. So I guess we need these cases. Actually, this is going to be key definition. So we're gonna have something like so this is gonna be line 1, 2, 3, 1, key name. It's already been defined. 3, 4, 5, 6, 7. Key spelling has already been defined, and then you're right. You're right, Python. That was never closed. Okay. If type table is not dict, then key redefinition iterator key. I think that's what we want to put in there. But now I guess we want to decide, what do we want to do? What do we want to do? I kind of feel like what we may want to do is just shove a dictionary in there and like keep going. Maybe. Yeah, let's do that. So let's do that. I guess I like that. But now we're gonna have I guess that actually needs to come out here. Right, because we should get oh no, if that's what we want. Okay. Oh, yeah, this is an error in the redefinition. Message is what I say. Been defined. Oh, and in this case we want iterator.errors.append error key.line key.const var message. I have a feeling we need to import redefinition. Error is not defined from all right, that passes. We probably want to make this a little bit. It'd be nice to say where it was already defined, but we'll just have to get to that when we get to that. So So we're gonna have fruit equals apple smooth, smooth true, and orange equals 2. Oops, what did I do there? So here I think I'm going to run into a parser. Gosh, I just refuse to put a colon. That's in the nose. Yeah, we need to handle a hole, which is fine, I suppose. What are we? 85. Well, token.type equals token type.hole. I guess we probably want to return parse numeric iterator, yeah. Depth parse. I guess for now, we'll do that for now. Okay. So thinking what we can do is actually stick this in here. So we're going to have what? Error. So 7 is what? 8, 9, 10, 11, 12, 13, 14, 15, 16. Uh, one, two, three, four, five, six. It's type int is not iterable. Hmm. Hmm. So I suppose I feel like that's kind of what we're saying. So we're up by one. Is that just because I don't know how to count? 1, 2, 3, 4, 5, 6, 7. We expected. Oh, I guess so. Okay. Yeah. I kind of really like how this is ending. Oops. When you think you're a Neovim and you just start spamming letters to your terminal. I don't know. I guess having all these double spaces is a little silly. Oops. Fun with white space. All right. So defining keys out of order. I feel like I don't really need to bother checking that. So apple is going to be type fruit. And orange is going to be type fruit. Apple, oops, skin is going to be thin. Skin is going to be thick. Boy, I suddenly can't type. Well, maybe not suddenly, but red color orange. Oh yeah. Well, I just meant the extra lines there. I don't know. It seemed like it was a little bit cleaner, but I don't know. This is fine. But yeah, you're right. It's just an excuse to not do anything. And we've got our pi example. So do we actually need to test anything with these? I guess we can, right? I guess we can. Well, I mean, that's kind of sort of the argument about tabs, right? Always use tabs because then you can set your editor to display tabs however many spaces you want, but I don't know. It's a little bit harder to do on spaces though because it's actual characters, you know? I don't know, I suppose there are what may be dumb is kind of just worrying about it anyway. I don't know. I'm so used to using spaces at this point. A bit odd. What's is Roslyn like a C sharp editor? Um, I'm a string. You can quote me. Name. Um, Foo. Location. San Fran. Um, I'm gonna need that to fail so I can just copy and paste that Unicode character. Oh, oh. I guess I didn't realize that was the name of the compiler. Oh yeah. Well, yeah. That's what. It's like what do they call that? Like a language server, something that like IDs can hook into. Well, that's what you just said. Yeah. You have a way to set that up with NeoVim, and there's a bunch of plugins for like different languages and stuff. Language server process. I don't know. I thought it was like LSP. I don't remember what it stands for. Um, but I feel like it's become like a right. You kind of like get a daemon going. So it's. I mean, I guess it's like literally a local server running on your computer, and then I guess that needs to hook into. I guess that's what the plugins are for, maybe. It like hooks into an interpreter or compiler for a specific language, and then I don't know. I guess the editor probably needs to say what sort of language it's running, but there's a way to set that up with NeoVim. I've just been kind of too lazy to do it. And actually, you know what? Since we're talking about it, I'm mildly curious now. What's going on there? What did I just do? I got failing tests, so that's fine. So if I go and then move what's going to happen here? Everything may go completely haywire. Oh, ruh-roh. What if we just quit? So where am I over here? Just do that. What? Oh, I don't know. I guess I don't have. Well, I was going to show you what I could do if I wasn't being so lazy. Oh, did it install it? Oh, it's installing all this crap. All right. So this is what NeoVim could do if I was being a little bit lazy about life. And I need to get more fonts installed, I guess. So now what happens? So yeah. So see, I could do it. I could do it. Test. What am I doing? Test basic string, I think. Oh, but yeah, I don't have my configuration in here, so. Ugh. The other problem with this is I'm not at all used to all the noise going on now. What's going on? No, I need a period. Anyway, so that is what life could be like for me. Oh, nice. Yeah, that is pretty nice. I agree, that's pretty nice. Okay, but enough of that. I'm done with that. So I don't know. One of these days, I guess if I'm not lazy, I should. But back to my grumpy old man editor. Uh-oh, wait a minute. Why is it still doing this? Don't do that anymore. Why is it still doing that? Something else got set somewhere. This is going to make me unhappy. Hmm. So I wonder where that's set. Does that mean I still have some language server, Hmm. That's a little bit annoying, I'm not gonna lie. I'm not sure what would have, what would still be sitting around for this configuration to still be here. Uh, well, that's what I get for screwing around with my... That is what I get for screwing around with my configuration, I guess. Hmm. Well, I guess I have to live with that for now. But that's so odd. Did it do something with my theme? No, still got the same theme. Hmm. All right, well. See, yeah, that's driving me crazy. Well, it must be some separate setting somewhere. I don't know. String 1 equals, so basically I just want to copy this. Roses are red, violets are blue. These are all going to be the same. Oh, really? Are we really, forgot I got all these under, so... Oh, yeah, right? There's an escape character. Okay. Uh... Right, this is, yeah, and there was an escape character, so we need to put that in there. So that was a lot of. Now what happened? I don't know. I live right over a road or like a highway, and occasionally I hear a crack up down there, and that's what I thought I might have heard. But it could have also just been a snowplow going by, because they really tear up the road too. But I really didn't want to spell multi-line correctly. Let's do line ending escape. Let's call this string 1, string 2. This is where I kind of wanted to have everything be the same. Why would you do that? Stop that. All right, that works. I feel like I may just want to. Well, I guess I'll just. Why not? Doesn't really matter. Here are 2 quotation marks. Yeah, that's what I'm hearing. I'm hearing snowplows go by. Oof. Here are 3 quotation marks. Here are 15 quotation marks. I really don't feel like typing all those in. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then string 7 is what? Oh, I remembered this, she said, would just be pointless statement. All right, that passes. Literal strings. I think I'm just gonna do something like that. Um, what happened there? I overwrote too much. Well, I don't know if you watched John Blow, but he uses Emacs, so he has quite a lot of viewers. Not that I don't know how many viewers. I don't know how much having a lot of viewers counts. I suppose. um. Okay, multi-line on the multi-line literal strings. I think I'll just do this again. Oops. I don't know why it does that. So where? Oh, I kind of screwed this up. Oh well. I don't need no stinking apples. I think I did use Emacs for a while, like back in college. Um, that goes away. I don't know. I guess the thing with Emacs is right. It's not modal, so it's just a bunch of shortcut keys and stuff. Oh, assert table. I will say one of the problems with getting used to using like Vim or NeoVim is when you're in a non-modal editor. I keep typing I to go into edit mode, so I just spam I's everywhere. So all right, integers. Integers. I'm probably going to regret this, but let's just do this here. So let's do that. Do that. Let's do that. Stop doing that. Let's come back to that. I actually don't know. This is probably not going to work. Like I feel like this stuff with the binary is probably going to be a parse error or something. Oh, well. I got complacent on adding these colons. We're not handling a so are we here? 91. Uh, 91. So I guess here this is going to be the same sort of thing. I really wish I knew what happened, like how this, because that is like, this must still be like plugging into some sort of language server or something. Like there's some sort of background daemon running. I don't know. That's probably what's going on. I bet if I reboot my computer, I just find out whatever's running, whatever daemon's running. Uh, it would probably go back to normal. Yeah, because this is doing this sort of thing where it's showing me where it's used and stuff, I guess. So here's what we'll do. We'll use peak token. So we'll go sign. Here's what we'll do. Sign equals token type that plus token dot type in token type dot plus, or feel like probably minus those. Probably I don't quite know how this works, but we're gonna want to eat. Let's set the sign equals token dot type, and then token is gonna be well, I guess we just want to eat that, right? Eat token. Result equals that. Which sign equals that's what we'll do. Integer 91. Token type dot integer. That's not what I wanted to do there. Well, that's really annoying though. We expected 99, we got I feel like I just so int1 what did I do here? Uh, so I'm not redefining int1, am I? Um, oh, I got this completely backwards. All right. So that makes me feel a little better. So that's passing now. Well, here's the actually I'm curious. Mildly curious. What do we get for these hex numbers? I feel like I kind of just want to put the actual integer value in there. And I guess this is used for octal, huh? What was this, 214? Okay. So far, this hasn't been too crazy. Oh, so now things are gonna get a little bit interesting. Floats. Go to that. Um, uh, oh, I guess because I'm not, right, I'm not, continuing to parse out that, those tokens. So I think in, right, I kind of just, put on the desk, or, oh, I guess down here. So, so I feel like what I want to do is, and actually, right, I think I made these separate tokens. So this is going to go to, I suppose, parse decimal. So what we want to do is we grab the whole. So let's call it that. If token dot type, and actually here we'll do, we'll bring back our time to float, or it's going to be false. If token type, suppose I should finish that out, equals token type dot period, then time to float equals true. And I guess what I want to do here. Maybe I guess I may want to actually just start building this up as a string, like I was doing before in the Lexer, before I did all this. so here's what we'll do. We'll do number equals that. Then we'll eat the token, and then the number will be the token value. Token that, and then number again will be token that value. And then this is just going to go to peak token iterator type equals period. Then we want to eat that token. And then we want to tack on that period. And we want token to be eat token iterator token type. What is this, fraction? And then number will be, and we want to set time to float equals true. And then we're going to have kind of the same thing here. This is going to be accept E. This is also going to be we're going to want to eat the token. Token that value. And okay, otherwise, so if it's not that, no, that's not what we wanted. So we want it, this is just going to be peak token. I don't know, I copied the complete wrong thing there. And I guess we can just do this as peak token. Maybe time for a little break here. All right. So if you get an E, we eat that. And this should be an E. I feel like I'm just typing gibberish at this point. We eat it, we stick that value on, and then token equals e token, and this is now going to be a token type dot exponent. Number plus equals token dot value, and then time to float is again going to be true. So if time to float, our result is going to equal float number, else result equals int number. Oop. Number, and we'll just return that result. Yeah, that should be indented. All right, dope. Dope, 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 dope. So this is coming along pretty well, I feel like. It's just kind of grinding through these examples. Uh, so this is going to be 2. Oh boy. So 2. Okay, so we need 19. That'll be 21. I think this is also going to be 21, right? Yeah, so here, what is our error? Something like missing whole part decimal number, something like that. And missing fractional part of decimal number. I feel like there should also I don't know, be something like um well, I suppose, okay. 1, 2, 3, 4, 5, 6. This is going to be 24, I think I just said. 24. 23. It's an exponential part of decimal number. I gotta close these. Implement non-decimal integer numbers. Huh? That was not the assertion failure I was expecting. Most definite. Huh. I guess I'll have to take a look at that. But I think first I need a little break. So I'm gonna call it 6 to be safe, I suppose. But I'll be back in a few minutes. Yeah. All right, I'm back, as you can probably see. All right, well, I gotta figure out what's going on here. So why do we think so what's going on here? We if we get a sign, if we get a digit. Oh wait. Oh, test invalid floats. Okay. It's not writing my tests in any particular order. That's interesting. So I guess I'm not... What do I have here? At this point, we have what? And how did we get here? Right? All right. I guess we could maybe have an E in there. I don't know. But I feel like... Oh, I bet this was failing on the first one, right? We look to see if we have an I or an N for the special floats. Well, we have a sign. We look to see if we have a sign. Then we look to see if we have a digit. And how do we get here? I guess... we might as well toss E in here. IN. So if it's a digit or it's one of these like special characters, we get in there. All right. Then what are we saying? Missing decimal hole, I guess. And I feel like at this point we want to assert oh well actually right, it could be E could be either case, I believe. Guess that's a little bit weird having just that E. I don't know. Right, because we'd have to also be missing. Right, there's like 3 things we would have to be missing. So okay, we're changing our mind on that one. So this is going to go down to our errors down here. So we're going to have message is going to be, what did we say? Missing a whole part decimal number. 434. Now we should be hitting Lexino digits. Yeah. So I kind of feel like so this is probably a little overkill. Where are we here? From 460? I guess I'm wondering how best to handle that. Part of me kind of feels like missing decimal fraction, something like that. Missing fractional part, and then we'll do like on error, and then on error iterator, something like that. Where are we? 428. This is going to be, wait a minute, this is not 440. Missing decimal whole, I guess. Oh, we don't know at that point, actually. We don't know. We don't know what it is here. Unless, unless we don't do this error handling in that function. So that's what I'm leaning towards. So yeah. So now we have to find where that breaks again. Where are we? Else, missing decimal fraction iterator. I guess that's what's up. That's what that's turning into. Missing decimal. Curious why we got none there. So we're Lexing floats right now, right? Else. Else, and this is going to be yeah, okay. Sure. So why does it feel like the errors are not whole errors? Buffer so why are we not getting any errors? The resulting table. Not that that should change anything, but um I guess we're gonna have to walk through this. What's going on Lex digits now? We don't need this used anymore. So we peek the character. If it's a digit, we add it to the digits, eat it. And it's okay to have an underscore. Otherwise, if it's an underscore, if it is not the case that underscore is okay, and the next digit or the next character is a digit, that's gonna be an error, but we'll just log that, eat it, and move on. And then it's not okay to have an underscore because you just say one. Otherwise, we ran into something else, and we're done. And then we just return the digits. So let's see here. Digits, so here we're not even looking at digits. We're just moving on to float. So here we check digits. if digits, otherwise we're missing a decimal whole number. What happens if I just do that? That is apparently not being called. Why is that not being called? Guess I should just get into the debugger here, but let's just see what this does. So we're getting a number. I guess we're not even getting the Lex float. Oh, wait, so why are we not getting the Lex float? All right, well, I guess into the debugger we go. So what we want to do is so let's break on tests on 423 here. Oh. Grr. All right. Still not sure why we're never calling that, but so there's still something going on wrong there. Maybe. Can I just well, let's just do self dot whatever what is supposed to be. Max shift equals none. Oh, seriously? Um, Expected a new line. Oh, okay. So what's going on here? Uh, I guess what we want to do is we want to just hexadecimal here. Oh, now we're there. Now we got there. Okay, well, it helps when your tools actually give you full error messages there. And not just like, hey, there's a lot of text here, buddy. I don't want to show all that. I only have like gajillions of cycles per second. I don't want to lex these extra strings. Okay. I guess I need to figure out at some point how much longer I'm gonna go on this because it's almost 10. Maybe I'll get through these values. Yeah. Well, date times are gonna be those are gonna stink. There's no denying that. So maybe I'll just get through these last few numbers. Set of numbers here, these special floats and these booleans, and call it a stream. I think we're going to want to import math here. Import math. I think I'm just going to do this again. What is this doing? Okay, thank you. Handle token type float. 91. Token type that float. E whole. Yeah. So we want to do that. I feel like I kind of want to do the same thing here. Token type plus. Sign equals token dot type. This is going to be heap token. Token dot type equals token. Then result is going to be token dot value. Else this is all going to get bumped in. This is going to get bumped in. This is going to be that. So if sign equals token type minus, then this is going to be, I guess we return that. Now we are 144 from 24. Oh, we gotta eat this. Actually, that should just be that. Oh boy, yeah. Nine and nevers never compare to each other, do they? Great. I wonder why I don't have an F here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, oops, 17, 18. Well, who knows after that? Who knows? Right one. I don't know. That's weird. Seems weird to me, at least. So what do we do about that? I guess we may have to special case that. I guess we may have to special case this test, right? How do we test if something is not a number? Let's see here. Uh, so let's test infinity. Let's break this out into two tests, I guess. Assuming, of course, uh, let's see if that passes. Looks like infinity passes. So results, our table, parse TOML, TOML, I guess. Um, so for key and table, guess we're going to want to do that. We're going to need to find cert in. I guess we'll just do assert true. It's probably what we want to do, something like that. Okay. Okay. And then I guess next is that all we have for these numbers? I guess so. And now we have bools. Test booleans. Test not a number. Test infinity. Test invalid floats. Test floats. Test integers. Okay, so far, so good. And with that, I think I'm gonna call that a stream. Um, I've actually been going for about 6 hours, so it's definitely time for a break and time for some food. But I'm pretty happy with how this is going. Quite happy, to be honest with you. I feel like I don't know. We'll have to see when we start getting the sort of more complex cases here. Um, how this goes. Lost my train of thought. But oh, and also when they start throwing like the TOML test suite at it for like invalid cases to see what our error reporting is doing. But yeah, this is going pretty well so far. I guess it's a good side of having to rewrite this. Um, so I don't know. I'll probably not hop on tonight. Let me try and give this a shot tomorrow. We'll see. But assuming I don't delete my code again, which I have it in version control, uh, I feel like another 1 or 2 sessions and I'd be pretty close to done maybe. Of course, having said that, it'll probably be another 3 or 4. All right. Let's just run our tests here. Looks like everything is okay. I think we want to add everything in here. Yeah, we don't have too many lines of code for this. So that's pretty nice. In fact, after I pulled all that crap out of main, that fake main function, we've actually dropped it from when we were done with Elixir. So that's cool. Finish lecture, start parser. All right, so with that, I'm going to call it a stream. I don't know if anybody's lurking. I think MKB probably took off. But if anybody is lurking, appreciate you stopping in. And until next time, I bid you peace and take care. See ya.